And again, this is the summary in the Martini version. So the thing is that arteries tend to have more elastic fibers, and especially in the tunica intima, this is why the endothelium in the artery tends to be rippled, and this is also important for the structure of the tunica media. So the thing is that arteries tend to be, again, arteries lead away from the heart, right? So these are the vessels that are closer to the heart. And elastic fibers, elastic arteries, they have a higher elastic fiber content than the other arteries in your body, and these tend to be located closer to your heart. And why are they located closer to your heart? Well, think of it, I like to use this analogy. So this is a fire hydrant, right? And the fire hydrant, well, where's the pressure greatest? Is it great as you go, is the pressure, water pressure greater toward the, right next to the fire hydrant, or further away you get from the fire hydrant? So the closer you get to the fire hydrant, the more pressure you experience, right? So your heart is very similar. The closer a vessel is to the blood flow leading from the heart, the more pressure it encounters. So again, your heart is always undergoing the cardiac cycle. It's always pumping blood, so it's always generating pressure. So your heart is a pump. And where you're going to experience the most pressure, the closer you are to the pump, the more pressure you have. But remember, we have a closed circulatory system. So we have all of these vessels that lead to and from the heart. So within these vessels, the closer you are to the heart, the more pressure you have in that vessel. Now, arteries need to be resilient. Why? Because again, they're dealing with the most pressure because they're carrying the blood directly from the heart. So the thing is that your arteries need to be like this. This trampoline, it's very strong, it's very resilient, it has elasticity, but remember your heart is always contracting and doing systole and diastole. You have all these changes in pressure within these vessels. So your arteries have to respond to this rebound and withstand all this recoil and pressure from the inside that's generated by the heart. Now, what if your heart or your arteries did not have that elasticity? So again, with the trampoline, you can do pressure on it, but it'll eventually rebound to its original shape, right? Now, this is what happens here. So here we have the heart, and now I'm going to draw that systemic circuit, but kind of stretch it out. So here we have our aorta, arteries, smaller arterioles, capillaries, which are very narrow and very small, and then they lead to larger venules, then back to veins, which eventually connect back to the heart. So I'm now just drawing the same vessels in a linear fashion. So again, this is why your aorta has the biggest pressure. Why? Because again, the heart is generating all this pressure, and it's going through the aorta, and then it's going to drop off as you go through these different vessels. The further away you get from the heart, the less pressure you have. Okay, and this is in graph form. This is why I showed that previous picture. So what we see here in this, the average blood pressure in these elastic arteries that are closest to the heart, you have the highest average blood pressure because why? It's closest to that pump. The further away you get from that pump, the less pressure you have. So these large veins, they have a lower average blood pressure because again, they're far away from the heart, but they also have a larger diameter as well. So this is another example I like to do. So what we have here we have a fire hydrant, and here we have two kids. So who's going to experience the more pressure? The kid that's closer to the fire hydrant or the kid that's further away from the fire hydrant? Let's ask the chat. So who's going to get the bigger impact? The kid that's closer to the fire hydrant or the one that's further away? Yeah, the kid that's closer, right? So what happens if you open that fire hydrant? Boom, the kid that's closer is going to be blasted by all that pressure from that pump. So this is the same thing, similar concept with the heart. The closer you are to the pump, the more pressure you have. Okay, so then, if you're sensitive to violence, you might want to look away. This is just from Hollywood, right? So this is what Hollywood likes to say. Okay, that's Hollywood's version of a blood spurt. But so does it necessarily gush out like that big red fountain we saw earlier? So that's another dead giveaway. You have an artery and not a vein. It's that blood squirt. Due to that increased pressure, again, arteries have a general greater blood pressure than veins. So another way surgeons can tell is like if you start squirting, you hit an artery. So yeah, that's what it looks like in real life. Blood squirts are real. They're not as extreme as that Hollywood version we saw earlier, but yeah, that's what we have here.
Remove the gut.
Again, the left ventricle is going to pump all the blood, and that's going to go towards the aorta. Since you're closer to the pump, in terms of systemic circulation, that's why the aorta has the greatest pressure.